For centuries, the Cascade Range has been a sleeping giant. Towering peaks like Mount Rainier, Mount St. Helens, Mount Hood, and Mount Shasta rise above the Pacific Northwest, monuments of fire sculpted by forces deep within the earth. To most, they look timeless, unchanging, a permanent skyline across Washington, Oregon, and Northern California. But in the last few years, something deeply unsettling has emerged. These volcanoes aren't just sitting quietly, they're moving together, breathing, in sync like a single living organism. Seismologists first noticed the strange pattern while monitoring low-level activity across the range. At first, the data seemed random, small ground movements here, faint tremors there. But then, when the signals were lined up, a shocking pattern appeared. The volcanoes were pulsing, rising and falling, not in isolation, but in rhythm, as if the entire Cascade Arc was inhaling and exhaling underground pressure together. Normally, volcanoes act as individuals. Each has its own magma chamber, its own plumbing system, and its own hazards. St. Helens erupted violently in 1980, while Rainier stayed silent. Shasta last erupted in the 18th century, while Lassen blew its top in 1915. They follow their own timelines. But these new signals suggest something else entirely. Instead of behaving independently, the Cascades may be linked, connected by hidden magma pathways that allow pressure to move between peaks hundreds of kilometers apart. To scientists, this discovery was alarming, because volcanoes aren't supposed to breathe in sync. Imagine watching Mount Rainier slowly bulge upward as magma pushes from below. Now imagine at the very same time, instruments at Mount Hood, 200 kilometers away, show a nearly identical movement. Hours later, the pattern reverses. Both volcanoes relax, deflating slightly, as though the system beneath them released pressure all at once. This has happened not once, but multiple times across multiple peaks. And it isn't just surface inflation and deflation. Seismic instruments are recording waves of tiny tremors that ripple through the Cascade Arc in pulses, almost like a heartbeat. Quiet, regular, rhythmic. But what does it mean? Some researchers believe the pulses are a sign of magma slowly circulating through a deep interconnected reservoir beneath the Cascades. Instead of isolated chambers, there may be a massive, shared body of molten rock, a kind of underground magma highway that occasionally surges, building pressure before relaxing again. Others suggest the breathing could be tied to fluids like water and gas escaping from magma as it moves upward, pressurizing fractures that connect one volcano to another. The unsettling part? No one knows how stable this system really is. If the Cascades are truly connected underground, then one eruption may not stay local. A blast at St. Helens, Hood, or Shasta could trigger sympathetic shifts across the entire arc, destabilizing multiple volcanoes at once.
The idea of volcanoes moving in rhythm sounds like a modern discovery, born from satellites, GPS, and seismometers. But when scientists looked back, they realized the Cascades have shown signs of breathing together before, only we didn't recognize it at the time. One of the clearest examples comes from the early 1980s. Everyone remembers Mount St. Helens, the mountain that blew apart in 1980 in one of the most infamous eruptions in U.S. history. A massive landslide ripped down its north face, followed by an explosion that flattened forests and turned day into night. But few recall what happened next. While St. Helens roared, seismometers placed across the Pacific Northwest started to pick up strange signals at other volcanoes: Rainier, Hood, even Shasta, far to the south. Nothing erupted, but tiny swarms of earthquakes rippled beneath them in the weeks after St. Helens' blast. At the time, researchers dismissed it as coincidence, or maybe sensitive instruments rattled by the shock waves of the eruption. But now, with decades of new data, a darker possibility emerges. Those swarms may have been the Cascades responding to their neighbor, like one lung inhaling as the other exhaled. And St. Helens wasn't alone. In 2004, the same volcano began to stir again. This time it wasn't a violent explosion, but a slow extrusion of lava, building a new dome inside the crater. As magma rose beneath St. Helens, GPS stations at Mount Rainier and Mount Hood showed small but measurable deformations. The ground shifted in ways eerily similar to what was happening at St. Helens. Again, no eruptions followed, but the timing was too precise to ignore. It raised a question no one wanted to ask. If St. Helens could trigger changes 100 kilometers away, what happens if a much larger volcano, like Mount Rainier, comes alive? Rainier is the giant of the Cascades. Its summit nearly 4,400 meters high, its flanks draped in massive glaciers. Unlike St. Helens, which is relatively small, Rainier has a vast supply of magma, and, more dangerously, an enormous volume of unstable rock and ice. An eruption here wouldn't just send ash into the sky. It could unleash lahars, volcanic mud flows that race down valleys at highway speeds, burying towns under tens of meters of debris. Now imagine this giant breathing in rhythm with its neighbors. If Rainier swells, and at the same moment Hood or Shasta shifts, it suggests these mountains are connected in ways scientists once thought impossible. And the deeper researchers dug, the stranger the evidence became. Ancient ash layers scattered across the Pacific Northwest reveal that eruptions in the Cascades often cluster in time. Mount Mazzara, which collapsed 7,700 years ago to form Crater Lake, erupted within the same period that several other Cascade volcanoes showed signs of activity. Some records suggest multiple peaks erupted within decades of one another, geological seconds in the scale of Earth's history. Taken together, the evidence paints a disturbing picture. The Cascades don't just erupt one at a time. They stir in waves, in clusters, almost as if the entire arc takes a breath, holds it, and then exhales fire. And now, modern instruments are telling us the same thing. The Cascades are breathing again.
The theory that Cascade volcanoes might be breathing together is more than a scientific curiosity. It's a warning. Because if these mountains are linked beneath the surface, then the risks facing the Pacific Northwest are far greater than anyone realized. On their own, each Cascade volcano is dangerous. Mount St. Helens has already proved it can erupt with little warning. Mount Hood looms over Portland, a city of more than 2 million people. Mount Rainier towers above Seattle and Tacoma, where entire communities sit directly in the path of lahars that could bury them in minutes. And further south, Mount Shasta dominates Northern California, with the ability to send ash plumes across the western United States. Now imagine these volcanoes not as isolated threats, but as parts of a single, restless system. If one starts to stir, could it send ripples of instability through the others? Could an eruption at Hood unlock pressure at Rainier? Could a swarm of quakes at Shasta signal a broader chain reaction? Scientists don't yet have the answers, but they're starting to understand just how complex this system may be. High-resolution seismic imaging has revealed zones of partially molten rock stretching far deeper and wider than anyone expected. Instead of neat, isolated magma chambers, the Cascades may sit on top of a vast, leaky network, a tangled web of molten pathways that connect the volcanoes like arteries in a living body. And if that's true, then the Cascades are more like a single organism than a collection of peaks. An organism that is restless, breathing, and potentially preparing for something much larger than any single eruption. The consequences of a synchronized awakening would be staggering. Imagine not just one eruption, but several across the arc, within years or even months of each other. Ash clouds outground air travel across North America. Lahars could sweep away towns in Washington and Oregon.
Infrastructure from Seattle to Portland could be crippled. And the economic cost would stretch far beyond the Pacific Northwest, rippling through global trade and food supply chains. History has already shown us what happens when volcanic systems act together. In Iceland, volcanic fissures have erupted in waves, triggering months of chaos. In the Aleutian chain, multiple volcanoes have erupted in sequence, disrupting shipping and aviation. The Cascades, however, are different. They sit in one of the most densely populated regions on Earth's Ring of Fire. What happens here won't stay local. For now, the breathing continues quietly, detectable only on sensitive instruments. There are no plumes of ash, no explosions, no headlines. But the data is clear. The Cascades are not as quiet as they seem. And if this breathing is the prelude to a new chapter in their history, then the Pacific Northwest may one day face a crisis unlike anything in modern memory. The mountains are stirring, and while the Cascades may look silent against the skyline, underground they are alive and breathing. The only question left is, what happens when they finally